Welcome back to my channel. I'm going to now show you how to use Cursor, and I will try as usual to build an AI model. So I will start with creating a Jupyter Notebook, and we do have two options. We can use an agent, so it's a conversational chat. Here you can see the window on the right. And as usual, so the prompt is build an AI model to predict stock prices. It's very general. I really want to see what it can do to help me. And the thing is, if I send this request, I get the reply that the agent and edit rely on custom models that require pro or business subscription. Please use a pro subscription or disable. So this one, it feels like, so I don't have Pro, so it's a trial version. However, it's a Pro trial, so I was expecting that I still could get the access to the Pro features. So it's possible that very simply I need to disable my API key, and I'm trying to, as it says, basically, so and add or disable the API keys. I'm not sure why it's asking to disable the, yeah, it's kind of weird. But then, how can I disable the API key? Can it help? No, it can't help. The thing is, I'm very new to this so cursor, and so okay, this is not really okay. So I have a bunch of extensions. I basically copied the extensions that I got that I was using originally in VS Code, and this software. So this is a new software that I had to install, this cursor software, but it basically takes the same extensions as VS Code, so it's very convenient. Okay, so not here. I'm a bit struggling to to find, but I think that well, I did set up the API keys a few days ago, and okay, so cursor settings, and so we must have something for keys models. Okay, so here it is. So turn off. So I'm using the OpenAI ChatGPT, and all right. So I just disabled the key and no, and I'm wondering if now this works. Okay. So basically, okay. Now I feel like I can ask it to. So this is the agent, and trying to build an AI model to predict stock prices. I'll help you to create a machine learning model. We'll use Python. Okay. Yeah, Wave Finance to fetch stock data. That looks good. I'll create a comprehensive solution. So this looks a bit like what I got from Manus. So different steps, create a new directory. Okay. Okay, yeah, this is very similar to Manus, and it says there's an error. Let's create a directory first, and you can run the commands. So that's pretty cool. That's really cool. I kind of like that. So it's creating the requirements file. Let's create a main Python script. Okay, so it looks a lot like Manus, to be honest. I'm quite surprised because it looks like it's doing the same thing, actually. Okay, so fetch historical. That is only for Apple stock price. Interesting. Right. So I didn't ask more, more detailed information. So like how far in the future should it predict stock prices? I didn't ask anything. Splits and compute the R-square score, something that I've seen in Manus as well. Okay. So it looks like the code actually is done. Okay, so now I've created the files. To use the model, first create a virtual environment and install the requirement. So I don't have to run this by myself, apparently. Okay, so it looks like it's working and create a virtual environment. Okay. Right. So the virtual environment is called VINV. Okay, that's not very creative. Okay, now it's going to so install the require module. Okay, I cannot find this. New release of PEEP, could not find the recommend file. So where was it created? And we don't have it. So where is it? There's a requirement. Where is it? Stock prediction. Did it save the file actually? Oh, I have to accept. I have to accept this file, and then it's going to be created. That's interesting. So I'm going to accept. And accept all the files. Doesn't look like I can. So I have to accept these files one by one. This is the profile. I don't know what to do with this. This is my file. I don't need this in the end. Okay, so let's try again with this. The requirements going to install. No. Okay. So where the hell is this file? If I go to the file explorer, does it? No, it doesn't even show anything. That's weird. It's stock prediction. Do I see here? No, there's nothing. Interesting. Okay, does it exist? Does the file exist really? I just saved it manually. But okay, I have no idea where are these files? Right, so this one is PowerShell, so I want to speed Git bash by the way. Okay, that's another thing. We have nothing. We created the virtual environment, but okay, now why am I a bit lost? It's because I don't know. I feel like so I want to activate the social directory, but wait, really? Okay. Okay, it doesn't say where from where I have to execute this, so this is basically done, but this one doesn't work. And on Windows, okay. Oh, that's what it says. Script. I should read what it says first. Scripts. And again, am I in the right directory? No. So like this. Okay. Right. Let's assume that this works. Now, so install. But still don't have that. Still empty. Anyway. Okay. So I'm not going to think too much. I'm going to save it. Okay. So I was in a different folder. I can't really explain why. not sure why it used another directory, but it's fine. And okay, it wants me to work here, so I'm going to work here. So I just save the things, right, okay, here, and this one goes here as well. Okay, so now this should work. It's going to take some time, but no, actually why is it so already satisfied? I'm not sure why it's so fast, but that's cool. And then, so let's continue. So just execute this. Basically, it's going to run the model, apparently. I'm not a big fan of command line, and I usually prefer using a notebooks. But okay, here we have the answer, and the R square is very high. Interesting, and then actual prices and project prices, which is really very nice. I don't know. It been crazy graph, so it was very fast. Um, I mean, I have to look in more into detail into what has been done, but so it actually looks very good. So I'm trying to understand. Okay, first, so every time we have an actual price, so say every day here on this date, we're trying to look at say the stock price value in 1 month. And so the actual would be the actual 1 month later stock price, and the red one would be what we can imply from knowing the data today, and extrapolate from the missing 1 month of data that comes forward. And so we can see that, so the blue line, well, strangely, the blue line actually is less volatile. I would be expecting that the predicted price would probably be less volatile. It kind of really deviates a lot from the blue line, but that may be something which is not really easy to understand. That we should investigate why do we have so much movement, and what I wonder also, the big thing is, the big parameter is like how much forward do we want to forecast? Is it 1 month? So that's also something that is very important. So it fetches data. So it really managed to do that the first time. So using the as usual the Y Finance, but contrary to Manus, it really managed to have it done the first time. So that is much appreciated. Now we see the model is a random forest regressor. So not really the kind of LSTM that usually would be used by typically, so Manus or in ChatGPT in general would be actually using this LSTM. And relative straight, so it computes some indicators. Okay, so right, so it takes all these data and then it tries to feed the model. Okay. Right, so the code is very lean. There's nothing much to say. But my question is, so if can I ask you a question? Yes. So we have to read probably what it's doing here. Let's go back to the description of what it's doing. The stock prediction feed, so fetching the data, the random forest regressor, visualization, etc. To use the model, first you create a virtual environment and you install the requirements. This could be fetch historical data, create technical indicators and features, train the model, make predictions. The model uses the following features. So we call the prices characteristics and the trading volume and 20-day and the 50-day. Okay. split the data, right? So how much forward do you predict the stock price? The next day's closing price only. So the target variable is indeed the last. So this is the last element that we've got in this data plot. Okay. So the close variable actually is going to be the one that indeed. And let's modify the call to allow for multi-day predictions or update the model to predict prices for different time horizons. Add a prediction days parameter. Modify the target variable to predict the prices ahead instead of just the next day. Update the visualization to show the predicted horizon. Added output to show the current price, the predicted price, and the predicted percentage change. Really? That's nice. The model now predicts 5 days ahead. Okay. And so we have this parameter. The important notes: the further in the future you predict, the less accurate the prediction will be. Yeah, that's I think actually that's why I think that the Menace result was bad, is because it was trying to do 1 month, which is almost, so this 30 days, but it's almost impossible to predict what the stock price will be in 1 month. And well, we could still have some interesting results, but it's true that Menace produced something that was absolutely, well, almost zero kind of return, whatever the situation of the market. So the prediction performance will decrease as the horizon increases. Yes, that would be interesting to make a plot of that. Short-term predictions for trading decisions, medium-term for trend analysis, and longer-term. It should be used with extreme caution and not used for trading decisions. So it says 30 days is like something, okay, we can analyze the trend, but it's not for trading, basically. So what I wanted to do is to create some kind of trading algorithm, and I wanted to do this prediction so that I can decide, well, how to trade, but it says basically you can't go for more than 5 days. Would you like me to modify the prediction horizon to a different number of days? Would you like to see how the model perform with different prediction periods? First, I'd like to know if it already actually changed the code. No, it didn't. So I'm not sure what this is, because it shows me the code here with the number of prediction days. Can I actually apply? Okay, I can change this and actually apply the change of code. So here, okay. So I would accept this, and I need to accept each of them. Well, this is not even a change, this one, but this one is a change. So I'm going to, okay, accept this, and now so we have the parameter for no. Okay, I think I'm kind of misunderstood. This is only for, I don't know what this is actually. This wait, that was a tick, and I ticked and nothing happened anyway. This one probably is to apply the chain of code, and okay, I have to change each line. It needs to be accepted. That's interesting. Can be time consuming. I wish there was a kind of build function to accept all the changes. There may be, but for the moment I don't see it. I'd like to see how the model performs with different prediction periods. Right, so that's a very good idea actually. And obviously, because there is a parameter of the class, it can call the class with different values, and so we train the models, and we can see the result with different number of days. So that's a very interesting outcome. Right. So again, so this one accept. Modify the code. I'll create a function that tests multiple prediction horizon and displays their results side by side. That's really cool. And do I have to accept again within the code? No. Was it Was it changed? I'm not sure. So plot results and okay, there's a prediction. So yeah, looks like it's working fine. And calculate display. So each for each period, I will train a model, make the predictions, calculate and display the elsewhere scores. Generate two visualizations, one line plot comparing the R2 scores, both training and testing across the different prediction periods, and subplots showing the actual versus predicted prices for each prediction period is really nice actually. It's really looks like the best practice for this kind of exercise. Okay. All right. So by the way, this one was not stopped, I guess, because I have this window and okay, let's just stop it. It was not very nice. I don't know how I'm supposed to close this. I will just click on the graph. So this one looks the same. Did it change anything actually? Wait, is this the previous one? And I have to, what is happening here? Why do I have to, why do I have two files? No, I'm a bit, I don't know what's going on. This one is the old one, so I just closed it, and this one is, I'm assuming this one is the new one, but, okay. Oh, I can't, what is happening? Something's happening. So again, going to run this, and I'm expecting that it's the new one, the new code. But I'm a bit lost here of what is happening. Okay, it looks like it's still the old code. So where's the new code? How can I run it with the prediction period? Prediction days is by default is 1, and then what it's going to do in the main part is going to plot, and predictions is the number of predictions. No, it's not the number of predictions. Make predictions. What is predictions? It's prediction days, yes, but okay, I don't get it. Did I apply this? Make predictions. Test multiple prediction pairs. It says that it's supposed to do that to test multiple prediction pairs, but that's not what I see. So now I'm lost. I'm not sure what is happening. Did I have actually two different? No, this one. We've been working on this one. Do I have the latest version? I've checked the code here. No, I don't have the latest version. Okay, so I just click on this, and apparently it's not the same file. So this one is stop prediction folder. What? Is that possible actually? That it's not the same file. I'm lost here. What is this? What is this file? Is it the same? The file one actually should have like return. Here it should return test score. Should return more. Should return the training score as well. And that's not what is happening here. So here I'm clicking again. Is it the right one? Yeah, this one is the right one. But I have no idea what is happening. Okay, here again I lost it. So I do this. So I just saved it. And okay, let's run and see if that works. But just the same thing again. And here, what is this? So I'm not running the right file. So again, if I ask a cursor to reveal in File Explorer, it basically doesn't do it. Yeah, doesn't do it. So I don't know what's going on with cursor. That's one thing. And here, yeah, okay, so it's basically displaying, as it said, the various things. But okay, so it looks like I'm not in the right folder or something, but it's very surprising because this AI stuff was working in that directory. And I can't even know, I can't even check exactly. So it is, where is this? Right, so where is this? That's a C drive? In the C drive. Stock prediction, really? That's weird. I don't remember asking for it to be here, but here it is. So I basically created the folder and I had no idea, and I was not even in the wrong. And I don't know what I'm doing here, but all right. Please, 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 please go to the folder. Okay, I'm a bit lazy, so I'm going to just run the Python file like this. But you see it's going to the users. Well, okay, this is the Python version. Then does it run? Does it run the right one? No. Of course, this one was not configured, so it's not the right Python, and that's why I'm supposed to run. So from bash, and so we're looking to be in the. So now I'm a bit not an expert in bash, but okay, that's good. And so let's run this from here, from the right directory. But I'm a bit puzzled by, okay, great. Okay, so what do we do? The training score is always very good, but that's kind of fishy. Why would that happen? And the R score for the testing is, so it's lower than the training, obviously, but it's kind of, so apart from that point, this point here for 5 prediction days, it's actually increasing with the prediction period, and it's not, the R square is not really decreasing so much for the training with the prediction period, so that's kind of weird. Okay, and okay, this is very, very weird. What is this? Okay. Now I'd like to know what is happening here. Okay, there's some debugging to be done, probably, because the previous graph that I had with the first version was great, and this one just looks like nothing. Okay, so again, this is for, so 1 day, and this one, I should have the same graph as the first version, but as you can see, it's completely messed up. And then 5 days, but then from that point, it's just like, it's not working at all. So is it because the order is not correct? The order of the dates is not correct. All right, but in anyway, something was working and now it's not working anymore. So is it still using the plot results? The plot result, this one, that one's what is okay, basically. So is it still running this anywhere? No, it's not used. So it's not using these plot results anymore. So test prediction periods. That's what it's calling, and then it's so calling this, and then make predictions, and then so it's storing the predictions. Yeah. So here we've got, so for each period we've got these, but I wish I could actually have this like. So I guess I still want to do this, and what is the argument? It's the df. What is df? df df prediction. Let's say this should be like this. Now it's predictor. Okay, I save, and yeah, okay, let's call it. Just want to have the graph, the original graph for each case, because that graph is working. Okay, so this is 1 day. This is okay. What do we got? The first time, 1 day ahead. Okay, cool. This is 5 days ahead. So well, it's difficult to see what is happening really. But for the 10 days, so here we see that well, actually it's not bad, which is weird. Okay, and then we've got 30, so it's actually very close. So it's kind of not really clear why. Right, and okay, so that's why I kind of say like this. Testing score increases, which should not be the case, and this one I have no idea what is happening here, but definitely something is wrong. I mean, what does it do? It plots, and the x-axis is the result actual index, the index, and then it's the result actual. Okay, and then it does the same for the predictions, so actual and predictions, and the x-axis is the result actual. So there we have this. So what is it within the result? So which is returned by this is this, and what is inside? So the actual value is the weight test. Weight test. Actual and predictions. Actual and predictions. So these are predictions. So this is what we the output of the make predictions, which itself is so the predict version of the model. Okay, nothing's weird here, and so these are the x values for x for the test, and we basically get them from training the model. I mean, this one was working, and this one was basically so this one was -1 before minus length of predictions. And close with an offset. So here the plot is so the close versus prediction. Do they have really the same? Yeah, the x-axis is the same. It's the same date, and here it takes. It's not the close. It's the close. So what I'd like it is to have a kind of offset. Basically, this one should be like shifted by the amount of predictions. Not really prediction days actually. Where's the prediction day here? There's no prediction day. The predictions are directly okay. So the predictions. Okay. These are okay. These are close. So okay, it's just truncates actually the data just to keep the right amount of data, given that the well, but yeah, okay. It's a bit weird. So the problem is always that the code generated, you have to understand it, and there may be something wrong, basically. Okay, one thing, general command is that usually what we predict is not the level of stock price, but it's the returns. So change the code to predict the return of stock prices instead of the absolute level of stock price. So this one, so returns percent changes, and yeah, that's much better with this. So I'm going to approve this change. I guess that it understood what I wanted to do. So I just made a change, but it's fine. Right, so here, wait. Okay, there's a lot of text, but here I'll modify the code to test different prediction per. No, this is not my. I've updated test multiple prediction per. Calculate the predicted percentage change. Okay. This is. Oh, again, so I'm a bit lost, honestly, as how this works. This was approved already. This is from here, and did it change? Oh, okay. So Control Shift Y, etc., or accept the file. Does it? If I accept the file, does it accept all the changes? I feel like yes, that is the case. So, okay, I just saved it. And okay, so how do I know that it's using the returns now? It's because everything is in percent change, so it computes the returns. And the target is again, so percent change with the argument pairs. This corresponds to percentage change for like 5 days period, and then it shifts the data as well. So this is the future returns. So this is from the future, so that's the target, but we don't want to train on this. It should not be the target of the training, obviously. Just something that so it's not given to the model. It's used for comparing the output. It's given to the model, but as a something that is compared to the output of them. Okay, so okay, I guess we can give it a try. But from the previous result, I think that okay, this is super shady. This result doesn't make any sense. This one also doesn't make any sense. So yeah, something is wrong, and I want to see. I want to see this. So now it's a return. Okay. I feel like it removed my code as well, so I'm not very happy about that. So now I have to, yeah, so there's an autocomplete at least. Okay, now I save and then I run again, and I want to see the graphs one by one. So 1 day prediction. Okay, so this looks like what I had from Manus, and so we see it's very close to 0, but actual return, so this is the 1 day return, and actual, so it should mean that is the target basically, and the predicted is what we are. So the predicted is trying to match the actual, but so the red one is trying to match the blue one, but it's at least this one predicted is less volatile, which kind of makes sense. it's going through the middle. So I like this a bit better. This as well. I mean, but we get it to 5 days ahead, and anyway, it's almost impossible to predict, obviously, what is going to happen in this case. But at least it stays within a certain range. It's around zero or so return. Okay. I didn't check the period, but the period is ridiculously short. And this one again with a 10-day prediction, which is similarly around zero. There's a bit more volatility. And okay, 30-day is, yeah. So 30-day, we could see some trend actually on the actual returns, but the red line is not picking up this trend. And so this is weird because it goes against the intuition that the score should decrease with the number of days in the prediction period. And the other thing is this graph is broken, and I could ask it to. Okay, the final graph seems wrong. Could you check that the x-axis variable and the y-axis variable match each other? Right. Yes, I noticed the issue in the final subplot visualization. The problem is that we're plotting the predictions and actual values again, different indices. So if you give the command that it says, oh yeah, I can see it, which is great because I can't personally see it immediately. I didn't make the code, and so it's very difficult to understand that. Okay, but let's see. It says it will correctly show, so I have some high expectation. No, no, it does not. It doesn't work. What did it do? I don't even know what it did. So add the dates to a result dictionary. So it basically added the test dates, but yes, we'd like to run the adjusted apt data. Yes. So it's trying to run it. It's not even the right directory, is it? It's not the right directory, and I'm not really sure what happened. Skip and continue. So this was the previous one. So it's working on this file, but it's running on another file. That's not very smart. So the problem in the graph has not been fixed. I see lines coming through all directions. Right, so it's a modifier in the code. For some reason, every time it changes the code, I lose the individual graphs for each prediction period. So I have to copy that again. Okay, let's accept the file. Let's save it, and I'm going to run it. So again, the training is increasing with the period, which is not great. Oh, that looks good. Yeah, it looks like it's what I was expecting, yes. Okay. So if we look into first 1 day, we have a lot of volatility, so there's a lot of randomness. And as we go to longer period, we can see kind of a trend. And actually, it looks like the reason for training becoming better with more days is that there's a trend that it can pick up basically, as opposed to if there's too much volatility, then it's impossible to predict what is going to happen the next day. So it's difficult to say really how this works for the moment, but I feel like for this short period, and given that we have some kind of very simple kind of trend here, yeah, does it mean that this works? Possibly, possibly, but I'd like to see a longer period. So wait, wait. So if I modify the code by myself, it's going to again like can I keep it, and is it going to overwrite, or is it the problem actually? It's like I am not. What is it the same? Yes, it's the one that the AI is working on, but somehow when I modify it manually, then it changes the code, doesn't it? I don't like this. I don't understand what it's doing. But anyway, so I want to change the. I could just ask basically start date, or so where do we call this the predictor? Where do we call this here? And what is the start date? Known, and then that is known. And so what the hell is this? I mean, so when we're asking Yahoo Finance, we're not given any date. Okay, please please set the start date of the stock price data to 1st January, say 20. 1st January doesn't exist, but 2nd January, okay, 1980. I modify the code. Great. Okay, then I accept this, I save it, and then I run it. Then it's going to take much more time for training the model, obviously. And so I'm not an expert in this AI model. Oh, there's an error. Um, that stuff. Input X contain infinity of values too large for the type. Is it too large? There's too much data. Is it a joke? How much data we have? 11,000 days of data, and this is too much. I don't believe it. I don't trust this. There's an error, and what is the AI doing about that? Can you solve? No, it doesn't know the output, so I have to give it the output. Right. The output of the script was we're trying to use the data from 1980, but some of the technical indicators are producing invalid values, adding the data validation, adding infinite values. Oh, the values, so the values are not correct. Okay, so it's not the number of values. So we need some safeguards on the. So I'm not sure exactly what it did to make sure replace. So everything that is infinite is going to be replaced by. Okay, so here. Okay. Right. Let's try again. So now there's a lot of data, so I expect that it's going to take longer time for the chat to train these estimators, 100 estimators. Right, so the R-square score is much lower. So, sorry, this is the training is 0.8 and the testing is 0. Not 0. Here, training is 0.9 and then testing becomes even worse. Here, training, so the testing gets worse every time. So there may be a case of basically overfitting, which is not surprising. Because whatever you give to an AI model, if actually I mean, the AI model is doing great, it can. I mean, if you give enough parameters, then it's going to reproduce the data that you ask. So indeed, we could say that the test R square is going to be the training R square is going to be very good. But what we matter about finally is the testing. It's like this is assuming that your model is trained and and you kind of simulate and you can test it against new data and you want to see if it works. Okay. Okay, there's a graph. So the R-square score for the testing is absolutely, it's not very good. It's possibly because so the training has been, this model is good at reproducing anything like with enough parameters, but for the testing, it just doesn't work. I mean, when you give it new data, the new data for the extrapolation, it's just not working at all. Even well, the 1 day is the best indeed, and then it kind of decreases indeed with the prediction. For some reason, 30 days is a bit better than test days, but still. All right, so now, so as I said, it's 1 day return is almost random, is almost noise, numerical noise. We can see that. But the 30 days is we can see some trainlet, so it's not completely random. Possibly there's some mini reversion or something like that. But what the 30 days prediction is doing is, so I can't zoom, but here on the bottom right, it's no, it doesn't. It's not even really trying to predict exactly something that works. So it's difficult to say what is happening if it's been and here we've got, it's only from 2016, okay, because this is the test data. Is it stock return for the different periods? So actual returns and 30 days predictions. So I'd like to see what happens during the test period. Sorry, the train period should match exactly, and then the test period should, well, probably this actually, I'm not sure, but this is probably just the testing period. It's pretty bad. And it is very similar to what we had in Manus as well. Anyway, but here we can see different time horizons. LB doesn't help at all, but whatever. Time horizon is clearly not great. Which is so. So this one is the test date. So this is not the training, but the test. So the result is this result test prediction. So this test prediction is the testing period, not the training period, because the training period, by default, by definition, they should match. The prediction should match the target for the training period. Training model make predictions. So on the test and not the training. Train model and get the predictions. Right, but we keep the training score. The training score is good, so this looks like our overfitting. So the typical case of whatever the period of training. Sorry, yes, not the period of prediction. The training is good. It shows that it matches well and in a way that's we expect. But because we're fitting too well, then it's possible that it cannot extrapolate. So if you give new data, it's not so the new data doesn't behave the same way as the data on which you have trained. So that's also one limitation of what happens in the so potentially in the financial markets, and there was also the warning from the AI when I asked to increase the prediction period. So the model features are based on historical data, which becomes less relevant for long-term prediction. So market conditions and company fundamentals can change significantly over longer periods. So the model predictions will typically decrease as the prediction horizon increases. That's what we observe, yes. So long-term prediction should be treated with extreme caution and not used for trading decisions, yes. Right. So and we don't see the result by epoch, basically, but it's possible that also we could see a kind of pattern of fitting by looking at the result by epoch, if there was such thing as epoch. I'm not even sure that's the case. All right, so I think that's it. It's quite a good result, actually. I'm quite happy because it could change the code dynamically. It could solve the issues that we saw on the graph without me having to understand actually what it's doing and what is the issue. But it found the issue by itself. We just have to tell it that it's not working as expected, and that's it. So in terms of expectation of output. So the other thing is it's not using the LSTM, so I think that we could probably ask it to use the so please replace the random forest regressor by LSTM model. So now I assume that we're going to have like additional hyperparameters for LSTM. And the other thing is trying to predict the Apple stock price just using the historical data of the Apple stock price, and this is not the best way to do things. So second lens, I'm imagining that it's just like Manus was doing. It's kind of the LSTM future. Um, so I'm wondering if this is something that is given as a parameter to LSTM. All right, so I changed it. We created a new architecture. Okay, so there's a certain number of units that needs to be given. So here, second length is to look back 60 days for each prediction. Here, what's going to happen is that when we give so the size of the data is going to be different because it needs to, we need to give the model like 60 days, and it's going to predict the next day. The performance matrix is changed to mean square error, modify the prediction process. Okay, it should be now better at capturing the temporal dependency. Okay, so let's see that, and okay, something's happening here. I'm not very sure, but let's say it's okay. Still, I have a lot of data. So I still have this prediction days parameter as well. But here, the sequence length is the number of steps to look back. So this is the mechanism within LSTM. So I would be assuming that this parameter is an input of the model. And I'm kind of looking for something that looks like we're inputting this into the model. So it creates the sequences. This means that we have to keep this window of data, and we can create a lot of these different windows. And so this is how basically it's given to the input is changed by doing this. Basically, it's not an input on HTML. It's how we give the data, which is different. So the length of the data will be according to this sequence length. Does it explain this? Not really. So added epochs, 50 epochs, and where is it running through the epochs? Train model, create LSTM model, epochs 50, batch size 32, validation speed. Okay, it's much smaller. I don't know why. Trend score. So here's the, okay, it's training the model with these epochs, but we don't seem to be able to see the wait. Okay, that's very simple. What is it? It's TensorFlow. Okay, so okay, it looks like TensorFlow is very easy to. It has very simple functions. This looks like also it's going to be very long. So I think that okay, I'm going to stop this. I think that I could make it probably a bit quicker, but having a smaller sequence length by also using, let's say, 1/5 of the number of units, like this, by maybe increasing the learning rate and having only 20, maybe 10 epochs. All right, so let's try with this. Also, yes, reduce the data. So use from say 2001. Okay. So less data and also less parameters in the AI model. So we have 6,000 days. And okay, so we don't see what is happening for each epoch. Okay, we just have the so MSE, which to me doesn't really, yeah, looks very informative. This is in terms of this mean square error. So this should be mean square error. So that's a squared. So if we compute the square root, we should get something that is consistent with the original data, which is in terms of return. Somehow it's not really the kind of debugging trail is not here. It's difficult to understand what is happening within the model. So it's probably more like a user focus coding tool. And if I want to have more information about the process, then I need to ask it to update that. The training error increases with the period. All right, and the testing error also. Yes, yes, yes. Okay, perfect. So that makes sense. Then, all right. Okay, so it's kind of here. One day, of course, it's almost impossible to predict what is going to happen. And the more we increase the period and the more it kind of picks some trend, and we can see that here the return is actually decreasing over time. So it's kind of computing a moving average. It's kind of the moving average type of idea. So we can say that it goes through the say the middle of the up and downs. It's not too bad actually. It kind of makes sense that we have this red line that goes through the middle, and that's it, because the rest is very difficult to predict, especially since we're asking here, for instance. So I'm looking at the 30-day predictions, but the how it's even 30 days long, even longer than the frequency of these up and downs. So it looks like very difficult to predict anything. All right, so that's an example where we use only, so as I said, the historical data of Apple stock price to predict the future stock price of Apple, but we could imagine adding more data, so other stock prices, but we could also add macroeconomic variables or FX stuff, and as we add more data, we should be able to get potentially a better prediction. But we need to work on this, and that will be the target of other videos. For the moment, I just wanted to see how Cursor can work, and I'm very happy actually with it. I think that it did a good job of explanation, generation of the code, modification of the code, debugging, uh, and be able also to have a follow-up here in this window on the right, where I can continue asking prompts on top of the previous prompts. So I think it's very good for incremental improvements. It managed to really change the model when I asked to do it, managed to successfully do all the changes. So I am very happy with the result. of this. And for me currently, I think that this Cursor software is so far the best tool that I've been able to use at the time. Now, this is a pro version, it's a trial, and I'm not sure what is the pricing setup. This is something to be checked as well. Is it worth paying for this? I think that currently, depending on the price, it would be worth indeed putting some money and using it for um, improving the efficiency of coding. All right, so that's it. That's kind of a conclusion for today, and I will continue looking at other tools and trying to also improve the model because this model is does not really work. Obviously, it's not very strong. It's not able to actually help in investing or trading. So the next videos will be also trying to improve the prediction capacity of my models. Okay, that's it for today. Thank you for watching my channel and see you in another video.